Well, in the last class, we talked about the mean, and it's not enough. It's not enough to describe the data, um, because some numbers are line, more clear cut, more centered to the mean. Some numbers are way spread out. So to use mathematics to describe instead of my words, oh, the words spread out. How spread out? How close to each other? We need to use the math, the language to do it. And the way we do it is for every number. For every number, we calculate its distance to that number. Okay? For example, let's say here is a 36. Then the distance from 36 to this number, let's make it easy, 35. We say the mean is a 35. And let's make it, this is a 37. Here is a 37. Here, the mean is a 35. The distance is a 2. Is a 2 higher. This season is above the average by 2. Okay? And let's say here is a 33. This one is a 33. And on this season is lower than average by 2. It's lower than the average by 2. And here is let's say is a 40. This season is above the mean by 5. This season. And here is below the mean by, if it's a 35, then that's below by 19. Is a negative 19. The difference is a negative 19. So sum is a positive. The difference, some number is the positive, some number is the negative. So how do we do it? We have the Excel expert here. So Ali used so calculated the average. But now I want to calculate each number, the difference, each number, the difference between the average and that number. So this one is 16 minus so this one I don't like electronics, to be honest. So then the first number is 16. Second number is thank you. This is so much nicer by hand. 24. 19. We stop. We use some large number. Give me some large number. 73, I remember. 45. Okay, 46. Okay. Oh, we have all these numbers. Okay. And the number, the average, is that on? The average, make it easy. 35. Okay. The average is 35. So we want to calculate the difference. So here is a 16 minus 35, which is minus 19. Okay. So this season, his performance is below his average by 19. And how about this season? 25 minus 35 minus 10. How about this season? Minus 11. 19 minus. What's the number? I only heard a couple voices. As a student, is when you need to learn this instead of just use Excel, and you do not have a sense. You do not have a sense what's going on. And 33 minus 35 minus 2. And I'm a little lazy. I don't do all the 22 seasons. So how about this season? 33 minus 35. All these are negative. Is below his average performance. What's here? 38? And now this one is positive. This means, the meaning of that is in this season, his performance is 38 more than his average. More than his average. Ten. 11. Okay. So how do we are trying to use a mathematical number to describe, to show the two superstars are different. To show the superstars are different. Some are negative below the difference. Some is a positive above. This one, the number, I don't, let me, I'm driving. If you want to say, Dr. Lee, what are you trying to say? I'm trying to teach the variance. The variance. Variance, very important. And standard deviation. Standard deviation. Five years from now, If you can still explain to people what is variance, then I feel I didn't waste my time teaching this class. Variance and the standard deviation. I'm driving there, right? Not yet over there yet. Let's say this is a superstar A, okay? Let's say another superstar B. Now I'm using fake number. And the average for superstar B is also 35. Let's say his is 23. And 37, 29, and 40. One, 32. Sorry. On the superstar B, the average, let's say, is also 35. Then, if we calculate the difference, so it's -2, okay? So the first season, he's 2 below his average. Here has a question. You say, is only 22 season is already gone. He's already old. He's ready to retire. If I'm a manager, both are retiring. So to find out these numbers is from the 22 season. So he's already retiring. He is also retiring. There's nothing saying, who should I hire? There's nothing. We are looking at the history data. We are looking at the history data. We are just trying to make a judge. Let's say, in the history, which one is better? Which one is better? These are already history data, okay? So this is why we know the average. And 37 minus 35 is a positive 2. 29 minus 35 is a -6. Minus 35 is a 5. So how do we, yes, these numbers are compared to this -19, -10, -16, plus 38. This number is, the absolute value is small. -2, +2, -6, +5. Okay? One way, mathematically, to describe the more segment or spread out, you would say, if we just add these numbers, they will cancel each other. which is not good, which is not good. Minus 10 and positive 10, they cancel each other. That's not good. So maybe you want to say, okay, we take the absolute value. We take the absolute value, add up. The distance, the distance, the distance to the mean, we don't care it is above or it is, we just add the absolute value, the distance, and calculate the average distance, the average distance. The distance here to the mean is small, as you can see. The average distance to the mean is large. One way is to do that. However, for the reason which I don't understand why, to overcome the sign, negative sign and the positive, statistically, they don't take the absolute value. They make it square. They make it square. Minus 19 square. Minus 10 square. Minus 11 square. They make it square. In this way, minus 10 and positive 10, they're all the same. They're all the same. They're all the same. I got tired to write for each one, but anyway. So here, they take the square. They take the square. They take the square. By the way, these are like noise. These are like noise. Apparently, this is more noisy because it's up and down, up and down. And this is more quiet. This is more quiet. The noise is the difference to the mean. The difference to the mean. Okay, you take all the square and you add up all the values. Here you add up. You get the big sum. You get the big sum. Here you get the big sum. You add up all these together and divided by we totally has 22. We totally has 22 numbers. Forgive me, I didn't write. And it's not divided by 22. Divided by 22 minus 1. It is always our sample size is n minus 1. This is our formula for variance. This is our formula for the variance. This is the variance. And let's say you you are the boss of the factory, and you produce shoes. You produce shoes, and the shoes should be the same size. The shoes should be the same size. Should be the same size. Of course, we human and a machine is not rocket science. Is not you're not producing rockets. So some shoes are slightly larger, some shoes are slightly smaller. Let's say this is ideally. I'm making this 35. It's easy to talk. 35 centimeter. 35 centimeter. Okay, so you wanted to see if the products are good. You take 100 shoes and you measure. Ideally, it should be 35 centimeter. And you measure 100 products. Of course, some is less, some is more. Okay? If your product is more centered, a little bit less, a little bit more, then that's good. If your product, your shoes is this, some of your product is this, and some of your product is this, even though the on average is a 35, you say, wow, this is not acceptable, right? Some of your product is much smaller, some is much larger. It's very noisy, unpredictable. And this one is a little bit. So this is good. Okay. So the variance is talking about how spread out. How spread out. For example, if one class, the final exam is 80, average, okay, final exam, the average score is 80. Another class, another next door is also 80. The average score is also 80. However, in this class, somebody is 100, somebody is 0, or maybe 10 or 20. In this class, almost everybody is, most people are between 90 and 70. Right? 90 and 70. And this class, some is 100, some is 10 or 20. Even though on average, they are the same. Clearly, the two classes are very, this up and down, this is not good. Not good. It's not acceptable. It's not acceptable. And I'll give you one example. You guys have some surveys for ranking your teacher. For ranking your teacher, how let's say the school. You give scores, and that is the teacher's final exam. You at the end of the semester, every student give a score to your teacher, right? Remember? And my score is the very center. Is the very center. And is the most center. This is a real, okay? It's not a faking. And other teachers, some students really hated. Some maybe it's you. I know. Yeah, anyway, it's not my there, okay? Really hated some of you. So the university said not just the average, highly raised the mean, okay? Important term. Not just the mean. They also said the variance, okay, they publish it in teachers, uh, you know. And they said to show is, and I'm glad I'm the most centered, which means you guys, I probably treat it's okay fair, which is the my highest goal. I hope I have treated you fair. It's high, to be honest. It is high. Huh? Yeah. They don't tell me which student. Okay, it's anonymous. Right. This is like statistics, right? And they publish, they give Excel page, every teacher, the average score, and the variance. I don't remember the variance. Sorry. Anyway, I'm the most centered, and my score is high. And but the most impressive is yes. Uh, they say I'm corruption. And by statistics, I can tell, by the number, I can tell those numbers are trustable or not. I'm teaching statistics, so I'm trying to look at if the number has some, does it smell right? Um, one time, one teacher, um, every student, he got his average mean is 100, which means every student give 100 score to him. Does that smell right? No. Right. Something, I smell something there. They publish it, and he's my friend of mine, so I would not say anything. But I just thought, wow, probably, I said probably he just filled by himself 100 scores. And some got 90, those teachers, they got 99.7, the mean. Even though it's not 100, this doesn't smell right to me either. You know, every student have a different test. This basically is everybody said 100. So statistics doesn't make you, you have some deeper, you get sharper. Okay, so here is a better. So the variance is important. If two classes, one class is more or less 80 scores, 70, 80 something, 90, 100 is even better. But if you are too much up and down, the teacher is not doing a good job. As a, I cannot blame everything to the teacher. At least does not work well. That's my term. That's my term. Okay. Um, so let's back to our PDF. Let's back to our PDF, which um, so you say this squared the distance. This squared the distance. Okay. The distance to the mean, and divided, this is tricky, divided by one less. And the reason why is one less, I can assure you, nobody can explain it well, including me. No professor can explain it well. They just want to make it more kind of confusing, more advanced. So you should know, okay, it is one less. Add all when the sample is very large. Right now it's a 22. It's okay size. If your sample like the average life of 1,000 people, then what you should divide here? What is here? One less is 1,000 minus 1 is 999. I'm talking about the 1,000 people. 1,000 people. Okay, that's 1,000. Let's say their average life. Let's say their average life is 80 years old. So is 16 minus 80. I hope this is a fake, okay? They don't live so short. 16 minus 80 squared, okay? 100 minus 80 squared. Are you following me?
Yes.
Then you add this square. Everyone is positive because it's a square. Because it's a square. Then you divide it by the one less, which is 999. When the number is very large, divided by 1,000 or divided by 999, this does not matter much. Right? Divided by 1,000 or divided by 999. This result will be almost the same. This is the variance again. And the symbol, the book here is a little bit scared. What's the symbol for the variance? This is the variance. What's the symbol? Of course, is as this. Where is that smiling face? Where is that here? Can I write now? Yes. The symbol is s squared. This means the sample variance. This means the sample variance. The variance, okay? And you will notice if the distance, if this is a 35 centimeter, and this is the distance, by squaring the variance units is something square. Is something square. Okay? And I want to add one thing. By squaring, listen. By squaring, if the distance to the here is a 10, square is what? 100. Okay? This becomes 100. This becomes 100. Do you see it? The distance is 2. By square is what? 4. Distance is 10. If the distance is 10, by square is what? 100. So this has some kind of amplification. There. If the distance is large, if the original distance is large, by squaring it makes even larger. Okay? The original distance is small, you squared, still doesn't grow much. Original distance is large. By squaring, become very, very large. When you add there, this become very, very large. You add them, this is become small. So the squaring has some kind of punishment. If your data is more noisy up and down, the variance will looks very bad. There's some kind of punishment. Okay, I still have some sand here, and the standard deviation is taking the square root. I have 1 minute. Taking the square root of the variance. This is a standard deviation. You read this part, chapter 12. Chapter 12, page 249. You read this part, okay? The distance, the mean. Okay, we stop here, okay?